Hello and welcome. Let me just make sure that I'm streaming. I've got a great episode for you guys here. Make sure we have a good connection. Make sure the audio is good. Welcome, welcome, welcome. There we go. All right, so hey nerds, it's Maddie Adams, and today you're watching this week's episode of Space News. So NASA's Artemis program suffered a major setback that has it rolling back to the vehicle assembly building. We have a lunar eclipse or blood moon happening March 3rd. Elon wants to make a moon catapult, and the U.S. Space Force plans to research in-orbit refueling. It's been a big week, so let's just get right into it. And so first off, this is just a really cool little graphic that NASA has just kind of showing the SLS system. So this is going to be important because we're going to talk about not only the hydrogen fuel leak that happened, but the helium repressurization issue that they're having. So let's just get right into that. So there's a rocket upper stage issue, preparing it for rollback. NASA's taking steps to potentially roll back Artemis 2 and the Orion spacecraft, and they definitely are rolling it back. So there was no leakage to speak of when the hydrogen came into it. So the exercise completed, the closeout procedures that prepare the capsule for launch and carried the countdown to just seconds before liftoff as planned. The team was also able to test countdown recycle procedures, which provides extra time to resolve minor issues on launch day and help avoid scrubbing the attempt. Teams were initially targeting March 6th, and they were really excited and all of that stuff, but continued monitoring showed that there were issues with the helium, basically repressurizing everything after the fact. So they're going to be moving it back to the vehicle assembly building. So the upper stage uses helium to maintain the proper environmental conditions for the stage's engine and to pressurize liquid hydrogen and liquid oxygen propellant tanks. So the system worked during NASA's Artemis 2 wet dress rehearsals, but teams were not able to properly flow helium during normal operations and reconfigurations following the wet dress rehearsal that concluded February 19th. So they're going to have to roll it back. Now we're probably targeting April or maybe May. So let me know what you think in the comments. Kind of a big issue here. Obviously, safety comes first. I don't want to kind of try to freak people out too much because, you know, at least the issue was spotted and at least they're doing something about it. But it is concerning. And teams are reviewing the potential causes of the issue, including the interface between ground and rocket lines used to route helium, a valve in the upper stage, which I believe that was the issue with the Artemis 1 rocket. They had another helium issue, so we're starting to see some parallels here. And in a little bit, we'll kind of talk about why the liquid helium and liquid oxygen that they use, not the oxygen so much, but specifically the liquid helium, can be a little bit problematic. So so the fuel set to propel NASA's moon crew is notorious for leaking. Like I said, we had a hydrogen fuel leak on Artemis 1 and on Artemis 2. It had to be rolled back on Artemis 1. On Artemis 2, they were able to fix it on the pad, but now they're having issues with helium. So if all had gone according to plan, 4 astronauts might have been returning just this week from a history-making 10-day slingshot trip around the moon. And I'm actually really irritated because I was going to be in Florida. I was actually going to be in Orlando the day of the launch. I think I would have been able to see it from where I was. So super disappointed it's getting rolled back, but I'm happy to know that they're doing the right thing and keeping the crew safe. So instead, NASA's engineers have been grappling with the rocket and fuel meant to propel the mission called Artemis 2. So we're going to get into here this pesky hydrogen leaks. So engineers pioneered the use of hydrogen as a rocket fuel in the mid-20th century. So at this point, it's becoming sort of a legacy technology. So this was before it was used for the Apollo moon rockets. And most of the launch vehicles that have opted for this fuel ever since, and they've all wrestled with leaks. So the Vulcan Centaur rocket, which is produced by U.S. military contractor, and builds on decades of legacy technology, uses hydrogen to power its upper stage. And in 2023, a fuel leak caused a fireball explosion during Vulcan Centaur testing in Alabama. And so they actually have a video of that. Let me make sure that, I don't think that, you guys getting audio? Well, either way, this is the fireball. Boom. So that's what it looks like when it explodes. But so it's just really interesting. Like I said, it's a legacy technology. And we'll kind of get into what SpaceX is looking into in the future for new types of propulsion. But hydrogen's leaky tendencies can be attributed to the fact that it's the lightest element in the universe, so it tends to find its way out of things that you want to try to contain it in. And it has a very low density, and it has to be cooled a lot in comparison to some of the other technologies that they're looking into. So hydrogen is sometimes considered more trouble than it's worth, given its propensity to trigger launch delays. However, it also offers the best efficiency advantage when it's used in a vacuum of space, and that's why some rocket builders opt to use hydrogen for the upper stages of launch vehicles, but make use of more manageable fuels for a rocket's first stage, which houses all the engines that give the initial burst. So then it goes into orbital rockets built by Jeff Bezos' Blue Origin or Elon Musk's SpaceX, for example, make use of alternative fuels such as methane or RP1, a type of kerosene, for their rockets' first stages. But NASA's Artemis moon rocket, called the Space Launch System, or SLS, still uses hydrogen for both the upper and first stage portions of the vehicle. And there's one not so obvious reason why. It was ultimately a congressional decision that came through via law that NASA had to use shuttle hardware and shuttle workforces and contractors to do the SLS. So, in other words, it uses it in part because the space shuttle also used hydrogen, and lawmakers wanted the SLS program to largely preserve the shuttle era workforces and supply chains. So, bureaucracy. Will hydrogen always be a problem? It raises a question because, yeah, they have leaks all the time. It would make you wonder why they always kind of have to fix it, and you'd think that it would be something that they would have a fix for now. But instead, it has to be kept at unfathomably frigid temperatures of minus 423 degrees Fahrenheit. And the infrastructure that contains it needs to be able to withstand frequent chills down to that temperature. So that's the problem, is the where the fuel is contained warps at that temperature. So Teflon is typically used because it's been the one that works best. There's just not a lot of options. So just very interesting. We're kind of getting to the point where it's a legacy. Hydrogen is a legacy technology, and we need to go past it a little bit. So introduction here. Let's see. But Raptor is designed to power the new reusable vehicle SpaceX is building, the Starship spacecraft and the Super Heavy rocket. So they're going to try to take a bunch of people into space, Moon and Mars. Let's get into the actual rocket here. So Raptor is designed to power the new reusable vehicle SpaceX is building, the Starship spacecraft and the Super Heavy rocket. And combined, these vast machines are designed to take up to 100 people into space, possibly to the Moon and Mars, with tentative launch of humans to the Moon. Oh, how old is this article? Okay, this is an older article, so. But there's no other rocket engine capable of producing as much energy out of liquid methane and liquid oxygen as the Raptor engine. Yeah, this article isn't really telling us much about how it works. But essentially, the methane doesn't have to be cooled nearly as much. So you don't have as many issues, and it's a heavier element. So theoretically, you should have less leak problems. But I think it's slightly less efficient. So, and here are just some really awesome infographics that I found. This is just nasa.gov /gallery/space launch system /infographics. So just some really awesome infographics that they made here. So this is the height of the rocket. The SLS is taller than the Statue of Liberty, just slightly shorter than the Saturn V. Shows you the total amount of thrust. The Saturn V had 7.5 million pounds of thrust, and the SLS has 8.8 million pounds of thrust. Just some I really like the way that they did these graphics here. I just wanted to kind of shout out their team because I know how hard it is to make a good graphic. So, and there were a few of these that I was looking through earlier that I wanted to look at. So this kind of just gives you an idea of all of the different stages of the rocket. So you have 4 RS-25 engines, the most efficient engines ever built. They provide a total of 2 million pounds of thrust for launch and ascent to space. Then you have the solid rocket boosters, 17 stories tall. Each one generates 3.6 million pounds of thrust, providing 75% of the total thrust during the SLS rocket's first 2 minutes of flight, and then they separate. You have the core stage, 212 feet tall. It holds 733,000 gallons of propellant to power the 4 RS-25 engines for 8 minutes, and that sends the rocket soaring to space at 17,000 miles per hour. You have the stage adapter. This connects the core stage to the ICPS and partially encloses it in space stage. And then the ICPS is the interim cryogenic propulsion stage. One RL-10 engine provides 24,750 pounds of thrust to send Orion to the moon. So if you're wondering kind of the differences here and why you have the first stage has the really big powerful rockets, that's because you have to have a lot of energy to escape Earth's gravity, right? And so I think that's why we're going to get to in a second, but the Space Force is researching things like in-orbit refueling, because if you could theoretically launch and then refuel in orbit and then launch again, you would be able to hit such insane speeds that you wouldn't be able to, because as this shows, 75% of the total thrust is used during the first 2 minutes of flight, and that's because you're fighting against Earth's gravity well. And then you have the Orion stage adapter, which carries small satellites to deep space where they can conduct world-class science for pennies on the dollar. And the Orion spacecraft, which is where the crew will go. So if you've ever wondered what the entire rocket capsule, all of that stuff consists of, this is the moon rocket. So there you go. Just a lot of really awesome infographics here. Like I said, this is going to be linked in the description if you want to take a look at it. Some of this stuff I was just reading through. But yeah, so that's kind of the issues that they're having. It has to do with the hydrogen and the oxygen. And then, like I said, the second issue that's actually rolling it back is that they use helium to repressurize it all, because helium's inert, it's not flammable. So they use helium in there to kind of keep everything pressurized and not have any issues with the fuel. And this got me thinking the other day. I was just actually last night when I was sitting there going to bed, I was like, if every rocket that we launch has a core stage that just separates, like what happens to all of those? Well, it turns out most of them are probably just orbiting our planet. So a Japanese company becomes the first to approach a piece of space junk in low orbit, and guess what it was? It was a stage. It was the H-2A rocket upper stage. So there are more than 2,000 mostly intact dead rockets circling the Earth. But until this year, no one had ever launched a satellite to go see what one looked like. In February of what year was this? 2024. A Japanese company named Astroscale sent a small satellite into low Earth orbit on top of a Rocket Lab launcher. A couple months later, it completed its pursuit of a rocket stuck in orbit for more than 15 years. So this is something kind of interesting to think about when we talk about all this space junk floating around in outer space, that every rocket that we launch, its initial stages just separate and end up going into orbit. So very interesting. And then we do have a lunar eclipse coming up. It's going to be in the very early mornings of March 3rd, and it's going to be visible in, I think, all of North America, Central America, and Asia. It's really just not going to be visible in Europe and Africa. So this kind of has all of the different times. So if you're in Central Time, it's going to be 5:04 to 6:02 a.m. to 6:02 a.m. Mountain Time an hour earlier, obviously. Eastern Time, you guys will kind of actually have the best chances. This will be actually when a lot of people are probably heading to work, 6:04 to 7:02. So on March 3rd, if you want to get a good view of the blood moon, and time and date actually does all of this. If you ever want to take a look at all of the different like full moons, eclipses, and stuff like that, I think it's timeanddate.org. They do a great job at these. So this is where space.com got that infographic from. And if you're curious why it's called a blood moon, it's because the moon actually turns red. So we have all different names for moons. I made a video about this, but really the only two that change how the moon looks is the blood moon and the supermoon. Now the blood moon turns red because the sun is going through the Earth's atmosphere as the Earth is between the sun and the moon. And so you're getting red light. It's kind of the opposite effect of why we see a blue atmosphere. So it's filtering out the blue light, and you're left with red. So, and a supermoon is just when the moon is at its perigee, its closest its closest approach to Earth. So it actually appears bigger in the sky. But if you ever hear any other moon terms like sturgeon moon, cold moon, all of these things are just kind of named after months and seasons. So it really doesn't make a difference as far as like the physical appearance. So, but there you go. If you want to see a lunar eclipse March 3rd, just get up a little bit early. If you kind of have like a 9 to 5 work schedule, get your butt up a little bit early, go outside, and you'll be able to see it. Now, it will be close to the horizon, so you're going to have to climb up on a building or something maybe. Or if you live in the desert, you might be lucky and you'll be able to see it. So, and let's get some water. So, like I said, when we were kind of talking about when you launch a rocket, it uses up like 75% of its fuel just to kind of get out of Earth's gravity well. And if we could learn how to, like I said, launch stuff from the moon or from in orbit, refuel things, it could really mean a lot. Now, this article specifically, I think, is talking more about refueling satellites, right? So that we don't have to continue to just retire satellites. So as it plans for a future in which satellites can be refueled in orbit, the U.S. Space Force has taken a step that signals intent. So like I said, they haven't really committed to it. This is just we're going to think about researching it kind of thing. So they sought industry input through a request of information, asking for technical concepts and approaches to refueling services for prepared clients in orbit, and with an expected operation date by 2030. That's a very positive step. So Astroscale is a private company. They're building a refueling vehicle, but they're partially funded by the Space Force, kind of a private government collaboration, preparing for its first mission in geostationary orbit. Oh, hey, Danny, how's it going? Sorry, I haven't been checking comments. I will, I'll get to the comments here at the end. Is that I don't know if that's the craft that blew up 6 times. All right. Yeah, so they're trying to figure out the different interfaces, how they're actually going to line up with these satellites that are traveling super fast and be able to refuel them in orbit. So it's all very, very much in the planning phase, but just kind of interesting because, logistically, it might actually be easier to learn how to refuel rockets in orbit than it would be to like build a whole moon base. So just something to kind of think about. And speaking of moon base, I can't have an episode without kind of talking about Elon Musk lately, I guess. So his latest scheme is a satellite catapult on the moon, and I don't know, I actually think it sounds kind of cool. So with this, and obviously the writer of this doesn't really like their idea or his idea, and apparently some of his engineers don't either. I don't really know how feasible it is. Somebody just kind of freaking said 2 weeks ago, so I'll have to kind of look into that a little bit more. But Elon Musk is making some wild new plans. In an XAI meeting with employees, Musk said the company needed to build an AI satellite factory on the moon with a gigantic catapult to launch them into space. Just the way that that's worded is does make it sound kind of ridiculous and far-fetched, but all of that would be a part of the billionaire's plan to create a massive orbiting AI data center that uses satellites powered by the sun and kept cool by the vacuum of space. But the transferring of that data is, I think where the issue lies is, how do you get that data, right? So any satellites launched from the moon would presumably orbit the moon as well, but he didn't really specify. So earlier last year on X post, yeah, Musk, I mean, he makes some interesting tweets though. So if you remember last year, he made a tweet saying that we're going straight to Mars and the moon is a distraction. And now he's saying, let's do a moon base. So I don't know. Elon tweets can be taken with a grain of salt, I think sometimes. He kind of, Anyways, but I'll upload this at the end too. I actually found this is the whole technical document. If you're really that much of a nerd and you're interested in exactly how the SLS rocket works and how the propulsion works on a more technical level, I'll make sure to link this in the comments. It's very interesting. Yeah, just let me know what you think about some of these stories. Are you concerned about Orion? Like I said, with it rolling back and having kind of some of the same issues that plagued Artemis 1? Or do you think that, since these are issues that we've had in the past, it should be something that, they should also know how to fix? So not a huge deal, right? Let's just hope that everyone's safe and that they're doing all of the right stuff. But so let's just remember that space is dangerous business. And so as much as it's disappointing that we have setbacks, it's important to make sure that we're doing everything safely and not just, hurling people out there and, sending them off to say goodbye to them, right? So yeah, just some really awesome stuff. I'll make sure to link all of these graphics for you guys below. Like I said, let me know what you think also about kind of what we do with our rocket stages and if we should come up with a better idea. I mean, maybe do something with them or maybe have kind of a way that they're going to plan to crash down or separate them further out, but then you're carrying more weight. So that's probably why they don't do that. Just all very fascinating stuff. And yeah, like I said, make sure you get out there, wake up early. It'll be a good time for you to get up early. You can see a red blood moon in the morning. All right. Thank you, everybody, for tuning in. I hope you enjoyed today's episode. I'm going to start doing these, I think, every other week, and then we'll do simulations every other week. Lots of other videos and shorts dropped in between. I've been trying to drop a short, dang near every day. So... and then a video or two during the week and a live every week. So, and I said, sorry for today's being on Wednesday. I was traveling for work. I didn't really have an option about my flight times and stuff. And so and the hotel internet was really bad. I planned on actually just making a video at the hotel for you guys. And instead of being live because I was going to be on the plane, I was just going to publish a nice video for you guys on Tuesday. But I'm happy I did it today because I got to take my time, find some really good articles for you guys. So I hope you enjoyed everything. I hope you learned, and I hope you have a wonderful day. Let me know what you think down in the comments. How much hydrogen do they need? Yeah, so actually, Danny, that's one more thing that I will get into real quick here. I forget what the name of the equation is called, it's actually like a paradox. So what is the name of the paradox where you need more fuel to get further, but the weight slows you down? So yeah, the rocket equation, and some Russian words, rocket equation, but so Danny, the more fuel you carry, the heavier the rocket becomes, which in turn requires even more fuel to move that additional mass. This creates an exponential burden. Increasing the payload or desired velocity demands a disproportionately larger amount of fuel. As a result, the spacecraft's weight grows so much that it becomes impractical to achieve high speeds or carry significant payloads, especially over long distances. So here we'll go to the actual source. Fueling up, Neil deGrasse Tyson. Wow, this is a very beautifully designed website. Yeah, so that is why. All right, well, thank you everybody for tuning in. I hope you learned something today. And yeah, I think obviously the takeaway here is we need better